You open a search engine, stream a movie, save a photograph, or ask artificial intelligence a question. The result appears almost instantly. It feels weightless. But somewhere inside a huge industrial building, thousands of computers are working to make it happen. These buildings are called data centers, and they are becoming some of the most expensive and power-hungry structures ever built. So what does a data center really cost? And why is artificial intelligence making them dramatically more expensive? Let's follow the money and find out. From the outside, a data center can look like a simple warehouse. Inside, it is closer to a power station connected to a giant computer. Long rows of servers process and store information. Networking equipment moves data between machines and across the internet. Cooling systems remove enormous amounts of heat. Batteries and backup generators keep everything running during power failures. Almost every important system is duplicated because even a few minutes of downtime can be extremely expensive. Imagine a large data center designed to support 100 megawatts of computing equipment. That is enough electrical capacity to serve a small city. Before a single server is installed, the operator needs land, roads, fiber connections, security, cooling systems, and most importantly, a connection to the electrical grid. Construction costs vary significantly, but a modern 100-megawatt campus may cost close to $1 billion before it is filled with computers. And the building may not be the most expensive part. The servers inside can cost even more. A traditional server contains processors, memory, storage, networking equipment, and power supplies. Artificial intelligence servers use extremely expensive accelerators designed to perform enormous numbers of calculations at the same time. A single advanced AI server can cost hundreds of thousands of dollars, fill an entire building with them, and the computing hardware may add several $1 billion to the project. Then comes the cost that never stops: electricity. Servers consume power every second they operate. Almost all that electricity eventually becomes heat, so the facility must use even more energy to remove it. Data center efficiency is often measured using a number called PUE, or power usage effectiveness. A perfect score would be 1.0, meaning every unit of electricity goes directly into computing. In reality, cooling, power conversion, and other infrastructure always consume some energy. A PUE of 1.2 means that for every 100 megawatts used by computers, the whole facility consumes around 120 megawatts. Operating continuously, that data center would use more than 1 billion kilowatt hours of electricity every year. At an electricity price of 7 cents per kilowatt hour, the annual power bill could exceed $70 million. Cooling creates another major cost. Some facilities use air cooling. Others use chilled water or liquid delivered directly to processors. Modern AI chips can produce so much heat that traditional air cooling may no longer be enough. Water-based systems can reduce electricity use, but they may consume large quantities of water. This creates difficult choices in areas where water is already limited. Every solution involves trade-offs between energy, water, cost, and efficiency. Data centers must also prepare for failure. Large battery systems provide immediate backup power. Generators can keep the facility running during a longer outage. Transformers, power supplies, cooling equipment, and network connections may all be duplicated. This redundancy is expensive. But customers are not only paying for computing, they are paying for reliability. The costs continue after the facility opens. The building may operate for decades, but computing equipment can become outdated after only a few years. New processors deliver more performance from the same amount of electricity. Older servers may become too slow and inefficient to justify their operating cost. Operators must therefore keep buying new processors, storage systems, and networking equipment. They also need technicians, security staff, engineers, maintenance teams, and spare parts. So how does a data center make money? Some companies rent space, electricity, and network connections to other businesses. Cloud providers sell computing power and storage by the hour. Artificial intelligence companies sell access to models running across thousands of specialized chips. Customers never need to see the physical machines. They simply pay for the digital service. A data center may cost billions to build, but the same infrastructure can serve millions of customers around the world. This scale is what makes the business so powerful, but it is also creating enormous new demand for electricity. The International Energy Agency expects global data center electricity consumption to roughly double by 2030, reaching around 945 terawatt hours. Artificial intelligence servers are expected to drive a large part of that growth. Globally, data centers may still represent only a few percent of total electricity demand, but their local impact can be much greater. A single large campus may require new substations, power lines, and additional electricity generation. So what is the real cost of a data center? The building may cost hundreds of millions or more than $1 billion. The computers may cost several billion. Electricity can cost tens or hundreds of millions every year. Then there is cooling, water, maintenance, security, staff, and replacement hardware. The digital world may feel invisible, but it is built from steel, concrete, copper, silicon, water, and an extraordinary amount of electricity. Every search, video, cloud file, and artificial intelligence answer has a physical cost somewhere, and as artificial intelligence grows, that hidden industrial machine is becoming larger, more expensive, and more important than ever. This is the real cost. Subscribe to discover what the world's most familiar technologies really cost.